Today, we'll be covering three core routing concepts: port address translation, route redistribution, and route maps. We'll start by looking at how PAT allows multiple internal devices to share a single public IP address. Then we'll move into route redistribution and see how to exchange routes between different routing protocols in a controlled and predictable way. Finally, we'll break down route maps and show how they give us fine-grained control over what routes we match, modify, and filter. Let's start with port address translation. Port address translation, or PAT, allows multiple internal devices to share a single IP address by translating the source IP and the source port. Each outbound session gets a unique port number, which lets the router keep track of thousands of simultaneous connections without any overlap. This is why PAT is often called NAT Overload. It maximizes the use of one public IP while still allowing every internal device to reach the internet. It's efficient, scalable, and it's the default method used in most enterprise and home networks today. We're going to start today's lab by configuring port address translation on both our branch 1 and branch 2 routers. Now let's take a look at route redistribution and route maps. Route redistribution allows different routing protocols to share routes with each other, which is essential when a network runs multiple protocols like EIGRP, OSPF, or BGP. When we redistribute routes, we must set proper metrics and apply filtering, often with route maps, to keep routing stable and predictable. This ensures each protocol receives only the routes we intended to advertise. Route maps give us granular control over routing by letting us match specific prefixes and apply actions like setting metrics, tagging routes, or filtering them entirely. They act as flexible policy tools that sit between routing processes, redistribution, or neighbor relationships. With route maps, we can precisely control what routes are allowed in or out of our routing domain. Now let's take a look at redistributing our static route from the previous video into EIGRP. Then we'll create route maps to control which EIGRP routes get redistributed, ensuring that our ISP does not learn any of our internal LAN prefixes.